It is one of the most striking visual anomalies on our planet. A border drawn in water. Two massive bodies of liquid, touching for thousands of miles, yet refusing to become one. The internet calls it a miracle, a place where the Pacific and Atlantic shake hands but stay separate. But the reality has nothing to do with magic, and everything to do with a secret physical skeleton. To find the true meeting point of the oceans, we have to look deeper into the physics of density. This isn't just a visual trick of light. This is a physical battle between two entirely different states of density. It is molecular warfare. Density is weight. High saline ocean water is heavily laden with dissolved minerals, making it massive. Glacial meltwater, however, is pure, light, and buoyant. This fractional difference in specific gravity creates an invisible pressure wall. One side can push against the other, but they lack the shared chemistry to merge. Much like oil and vinegar, the surface tension of the molecules creates a skin between the two. They are touching, but they are technically miles apart. This is the Halocline, a wall made entirely of salt content. Salt water is dense and heavy. Fresh glacial meltwater is light. They literally cannot occupy the same space. On a molecular level, they are moving at different speeds. They collide, but they don't blend. It's a phenomenon similar to oil and vinegar. The surface tension acts like a physical skin. But salt is only half the story. Meet the thermocline, the wall of heat. When currents of different temperatures meet, they don't mix, they clash like tectonic plates. The cold, dense water is forced downward, plunging thousands of feet into the dark abyss. This downward plunge creates a massive underwater pressure gate that keeps the surface waters divided. The final force is the Coriolis effect. The very rotation of the Earth pulls these oceans in opposite directions. The oceans do eventually mix, but it takes centuries of deep-sea travel to break these invisible walls. To understand the wall, we have to leave the surface. This is the chemical divide. Glacial meltwater is thick with rock flour, fine minerals ground down by massive sheets of ice over thousands of years. Ocean water is a different world. It is a high salinity solution of sodium and chloride. When these two chemical signatures meet, they create a diffusive boundary. A liquid barrier that blocks mixing. The silt makes the fresh water sticky. It clings to itself, refusing to let the salt water penetrate. Even the massive kinetic energy of a passing ship isn't enough to blend them permanently. This is known as stratification. The waters aren't just side by side, they are stacked. Think of it as a liquid skyscraper. The heaviest floor is always at the bottom. Meet the pycnocline, the invisible ceiling that traps the fresh water on the surface. This barrier doesn't just block water, it blocks life. Different ecosystems thrive on each side of the wall. For many marine species, this line is as real as a concrete wall. The change in salt would dehydrate them instantly. But if we travel to the Drake Passage, the wall becomes even more violent. Here, the currents are moving at incredible speeds, yet the border remains intact. Temperature is the second gatekeeper. The cold Pacific is a sluggish liquid. The warm Atlantic is active. When they collide, the Pacific dives. It plunges into the dark abyss, searching for a density match. This underwater waterfall is one of the most powerful energy transfers on the planet. This plunge drives the global conveyor belt, the system that regulates our planet's climate. If these oceans mixed easily, this conveyor belt would stop. The Earth would freeze. The invisible wall isn't a mistake. It is the Earth's life support system. Two oceans, two worlds, touching, but never truly meeting. To find the final gatekeeper, we have to leave the ocean entirely and look at the planet itself. This is the Coriolis effect, a force generated by the Earth's 1,000 mile-per-hour rotation. The rotation of the Earth pulls these oceans into separate, massive loops called gyres. Like a giant centrifuge, the planet's spin physically prevents these two bodies of water from merging into one. In the north, they are pushed right. In the south, they are pushed left. They are locked in a planetary dance. This force is subtle, but over thousands of miles of open ocean, it becomes an impenetrable wall. The oceans aren't just sitting there. They are pushing against each other with millions of tons of pressure. The Atlantic is actually slightly higher and saltier than the Pacific. It's a literal liquid staircase. Because of the density gap, the Atlantic sits nearly 20 centimeters higher. A ship crossing the line is actually sailing uphill. This height difference creates a constant, microscopic leak of water, but never a full blend. Weather patterns also play a role. The clouds above the Atlantic carry more rain, fueling the freshwater cycle. The Atlantic loses more water to evaporation than it gains from rain. It is constantly becoming thirstier. To compensate, a deep-sea current, the Great Ocean Conveyor, pulls Pacific water in from the bottom. The blend does happen, but it takes a 1,000-year journey through the dark abyss to accomplish it. At 12,000 feet deep, the colors vanish. The invisible wall finally crumbles under the weight of the world. Down here, the salt and temperature eventually find balance, but on the surface, the war continues. This surface line is just the top of a massive, 3D puzzle that keeps our climate stable. If these oceans mixed instantly, the heat distribution of the planet would collapse. The wall isn't a glitch. It's a feature of Earth's biological life support system. Two oceans, two worlds, touching, but never truly meeting. This isn't just a border for water. It's a border for life. A biological wall. Glacial meltwater is a nutrient soup. It's packed with iron and nitrates that trigger massive plankton blooms. The high saline ocean water is nutrient poor. To the life on the other side, this water is a desert. The concentration of life on the teal side is nearly 150 times higher. It is a floating garden. For a fish adapted to glacial water, crossing this line is a death sentence. The sudden salt spike would dehydrate its cells instantly. Whales and large predators use this line as a hunting fence. They drive their prey against the wall where they have nowhere to run. It is a massive, invisible curtain. On one side, a buffet. On the other, a void. The physics of osmosis keeps the border clean. Any freshwater organism that drifts across is biologically burned by the salt. Even at night, when the light fades, the chemical wall remains. The organisms stay in their lanes. Salmon use these glacial scent trails to find their way home. The wall is their map. If the oceans mixed instantly, these scent trails would vanish. The migration of millions of species would fail. The separation isn't just a visual trick. It's a survival mechanism for the entire coastal ecosystem. Look at the density. The world is literally divided into two different biological realities. Even in a single drop, the DNA is different. These waters have been separate for millennia. By staying separate at the surface, these waters preserve the biodiversity of the planet. When the sediment finally sinks, it feeds the creatures of the deep. The wall is a delivery system. This non-mixing zone is one of the world's most effective carbon sinks. It traps greenhouse gases at the bottom. The invisible wall is the silent engine of the ocean's health. To the human eye, it's a beautiful mystery. To the ocean, it's a necessity. Two oceans, two worlds, one delicate, unbreakable balance. But these invisible walls are not permanent. They are built on a delicate balance of ice and salt. As the world warms, the balance is shifting. More fresh water is entering the system than ever before. The liquid border is moving. The freshwater carpet is getting thicker, and it's spreading. Data shows the Halocline is deepening. This means the surface of our ocean is becoming fresher every year. If the water becomes too fresh, it loses its density. It loses its weight. It stops diving into the abyss. This is the nightmare scenario. If the invisible walls vanish, the engine of our global climate fails. Without the separation of these currents, the heat distribution of the planet breaks. The north freezes. The beauty of the line is that it represents a world in perfect, segregated harmony. It is a visual reminder that even in the vastness of the sea, there is order. Salt, temperature, rotation. These are the bricks and mortar of the ocean's architecture. Every day, a billion bubbles cross the border, but the wall remains. Despite the changes, nature is resilient. The physics of density are hard-coded into the universe. The invisible wall will continue to stand as long as the Earth continues to spin. We see the world in lines and borders, but the ocean sees it in weight and energy. There are thousands of these borders hidden beneath the waves. We are only just beginning to map them. The mystery isn't that they never mix. The mystery is that we ever thought they should. Two oceans, two worlds, touching, but never truly meeting. Don't just look at the map. See the structure. Join the next expedition. Subscribe.